Hi Year 12s. Today we're doing feasible regions, exercise 23C. So you can copy down the notes and I'll talk about it in a second. So pause the video when you need to. Alrighty, so we've already done graphs before, and remember how we did a test point, and then you can shade whichever side of the graph that you want. But a feasible region is on a graph. So basically you might have 3 or 4 different lines, so all through the graph. But a feasible region is a region that satisfies each equation. So it might be in between all the lines, there might be a section that's appropriate to all of them, all of the different equations, and then that's the region that we want. So I said here, the way to do this, from word questions, write down the equations of the constraints first, and then graph them. So we're going to go through an example right now together. So a paint shop sells brand X and brand Y of paint. It only has room for 100 cans of paint in total. It says there, it is known that at least 30 cans of X and no more than 50 cans of Y are required. So from this information, we have to write down some equations. So the first one that I can see, it says there, it only has room for 100 cans of paint. That means that the number of X and the number of Y brand in total can only be a maximum of 100. So the way we can write this equation, firstly we've got to define the variables. So I should say, let X equal number of brand X and let Y equal number of brand Y. Okay, so that was a given. Okay, so now the first one is number of X plus the number of paint of brand Y. It says there it can only be a maximum of 100. So that means it must be less than 100 or equal to 100. Because it can be equal to 100 or less than 100 because they've got room for a maximum of 100. Alright, let's look at the next bit of information. It is known that at least 30 cans of X are required. So that means X must be at least 30. So X is greater than or equal to 30. Because X can be equal to 30 or more than 30. Okay, and the last one it says, and no more than 50 cans of Y are required. So this is a bit of a tricky one. It means Y can be 0 and no more than 50. So Y, the number of brand Y is in between 0 and 50. So the way we write this, we can write 0, it can be equal to 0, and there's Y, and then we can put 50 in there. See there? Y is equal to 0 or greater than 0, and it's less than 50 or equal to 50. So because it says no more than, that means it can be 50 as well, but can't be more than that. So when we sketch this one, there's actually 2 separate lines that we're going to have to sketch on our graph. Alright, let's do that right over here now. I'll start off with the easier ones. Remember when we sketched X is greater than or equal to 30, we sketched X equals 30. So where's that? There's X and there's 30. So it's a vertical line that goes through there, and I'll even label it. So X is equal to 30. That's the equation of that graph. Alright, let's do the Y ones next, because they're going to be horizontal graphs. Y is equal to 0. Okay, so Y is equal to 0. There's our Y graph, and there's 0. So it's actually across here, across the x-axis. And I'll label that one, Y is equal to 0. So that's that line across there. Now the next one, Y is equal to 50. So we have to look at 50 here. There's Y is equal to 50. And it's a horizontal line that goes straight across there. And I'll label that one, Y is equal to 50. So far we've got 3 lines. We've got the vertical line and the 2 horizontal lines across there. Now we've got the harder one. X plus Y equals 100. So X plus Y equals 100. We need to do a little bit of work for this one. So the y-intercept, remember that? Y-intercept, let x equal 0. That equals 0, so it says there y equals 100 straight away. So our point is 0, 100. And then the x-intercept, let y equal 0, so we get x equals 100. And so our point is 100, 0. Hopefully you know how to work that out. If you had an equation that you had no idea about, put it into CAS, into your CAS calculator, and it will show you what the graph looks like. So we've got our 2 points, 100, 0 is there, and 0, 100 is up there, and so it's a straight line that goes through these 2 points. So I'll connect them up like that, and of course I haven't done it to scale, so it's not the best diagram at all. And you notice, I should mention, that all of these equations are equal to as well, so they're all solid lines. If they weren't equal to, remember what it would be? It would be a dotted line. Alrighty, now we have to work out where our region required is. Where's our feasible region? Let's start with the x one. X is greater than 30. So that's our line of that. X is 30 there, it's greater than is this side of that line. So this kind of gets messy after a while. So we're on this side of that line. Okay, and the y ones are easy. Y is greater than 0 and less than 50. So there's our y one, it's greater than 0 and less than 50. So it's in between, so it's above that line and below that line. So far we've just got now this region here, and we just want to know, there's that equation, do we want below or above it? So is it this region here, or is it that region there? So how do we do it? We do a test point. Test point, remember this? And I'm going to pick, for this line, I'm going to pick 0, 0 again. So 0 plus 0, but this time we need to put our equation in properly. X plus y is less than or equal to 100. So we get 0 plus 0 is less than or equal to 100. Is that a true statement? Yes, it is a true statement. So that means that this point here is in the feasible region, if you remember that from a previous exercise, which means there's our equation. I'll do this one in red if you like. There's our line down there, which means this point is in the feasible region, so it's below that line. So it's below, but remember, okay, I'll just draw it in like that, so it's below that line. Now from all this mess, we've got to work out which bit is appropriate to all of those graphs. So we know it's above that line, it's below that line. It's to the right of this vertical line there, and it's below that line there. So that means the region that we require is this region in here. So that region there, and then you have to somehow use a different colour and indicate that region there, not including that little bit there. This is the region required. Okay, hopefully that makes sense to you all. And now, there's one more thing we need to do, and that is, we need to find, it says down here, you need to find the coordinates of each corner point and label each point. So if you want to get full marks on a graph, you need to label. Now these are the corner points. There's one, there's another one, there's another corner point there, and there's a corner point there. Alright, so this one here is 30, 0. So we'll label it 30, 0 is our corner point. Now this one up here, it's 30 and it's 50. So that point there is 30, 50. We'll leave that one for a minute. This one here is 100, 0. So we've got those three. Now this one here, it's on the border of that line and that equation of y equals 50. So how do you find the point of intersection? And you use your CAS calculator. So remember how we've done simultaneous equations? I'm just going to look in my, to work it out. And it doesn't, it's 50-50 I think. Okay, and that point there is 50-50. So according to the textbook, this is question straight from the textbook. So now that we've labelled all the points, you've pretty much finished the question. So to answer the question, to show the feasible region, it's any point inside this region here is a potential solution to our problem. So, and I was mentioning integer solutions. That means whole numbers. So you've got 30, 50, and then you've got 31, 50, 32, 50, and so on. So at any point inside this region is a possible solution, and that includes along the boundaries as well, includes the corner points. So good job everyone. I'll do another example in a second. A12s. Another example, indicate by shading the region that satisfies all the following constraints. So at the moment, we're giving you the constraints and asking you to graph it and then shade in the region required. The harder questions, which you'll do next exercise, which is the last one, you'll get a whole bunch of words and you have to come up with these constraints yourself. And that's the trickiest bit. Okay, so firstly, if you've got 4 equations here, you can do it on your CAS calculator. So in the graphs function, you type in these equations like that, and then when you graph it, it'll actually draw the graphs and shade the region for you. So it does it all, but then you just have to find all the points if you're going to do it on a stack or something. But we're going to do it manually here. So, First, for this equation, 3x plus 8y equals 24. I need to find the x and y intercept, so I'll do that really quickly. Y-intercept, let x equal 0. So that's 0. I get 8y equals 24, y equals 3. So that point is 0, 3. Okay, then I go my x-intercept, let y equals 0, and I get 3x equals 24, x equals 3, 8 to 24. So that point there is 8, 0. So I've got my two intercepts, that didn't take long. Now the next one, we've got 3x plus 2y equals 12. Y-intercept, let x equals 0, we get 2y equals 12, we get y equals 6. That point is 0, 6. And we go x-intercept, let y equals 0, 3x equals 12, x equals 4, that point is 4, 0. Okay, so that didn't take long at all. We've got our x and y intercepts, so let's now go over here and graph them. So let's do the first one, 0, 3 and 8, 0. So let's say 8 would be roughly there, and 0, 3. Okay, so 0, 3, and there's my first graph. And you notice it's a solid line because they're equal to as well. They're all equal to, so I can do all solid lines. And what must you do? You should label the point there as well. Label the equations. That's 3x plus 8y is equal to 24. That's the equation of that line across there. Alright, and the next one. We've got 4, 0. I'll do this in another colour. We'll call this one the blue one if you want. Oh, we've already done blue. That's alright, we'll do blue. So we've got 4, 0. So 4 is about there. And 0 is 6. So it's roughly twice as high. And then there's our equation there. Excellent. So we've got those. Oh, and now we have to do the other ones. We've got x equals 0. That means on the x-axis it's equal to 0, so it's a vertical line that goes up there. So there's that one, and that one's x equals 0. And y equals 0 is easy as well. It's the y value is equal to 0, which is there, and it's a horizontal line across there. We'll label that one y is equal to 0. Alright, so now let's have a look at what we've got. We've got a vertical line and a horizontal line there, and then we've got an equation that way and an equation that way. So we need to find out where is the region required. So it's not always in that little gap. It could be in this gap here, it could be there, or it could even be above there. So we need to do a test point. And there's one more thing we also need to do. We need to find here this point of intersection. I suggest, rather than do it manually, use your CAD's calculator. If you graphed it, you could find move your cursor to that spot and it will show you the value, or you use simultaneous equations. I'm just going to look here and it's 8 over 3 and then comma 2. So 8 over 3 comma 2, which is 2 2/3, so 2.66667 if you worked it out. So now we've labelled all the points. We've got every single point label. Okay, we know that x is greater than 0. So x is greater than 0, so we know it's that way. We know the y is greater than 0, so it's that way. So we know it's in this quadrant, so it's in here somewhere. So now we just need to check these other two. So let's do a test point. I'll write here what I'm doing. Test point, 0, 0. We'll do it for this one first. So 3x plus 8y, and the equation is greater than or equal to 24. So 0 plus 0 is greater than 24. That is not true. So this one here, that point, I did the test point as 0, 0. So for that equation, that point is not in the region required, which means the region required for this line is not below it, it must be above it. So therefore, it must be somewhere above there. Does that make sense? Because there's our equation. Now we do the same one for the blue one, the blue line there, which is, oh, and I didn't label it, did I? Okay, so I should label it 3x plus 2y is equal to 12. So I'll do the test point again for this one. 3x plus 2y, but you need the inequality is greater than or equal to 12. 0 plus 0 is greater than or equal to 12. Is 0 greater than 12? No, it is not. So therefore, that point there, that test point we used, for this line, that is not in the region required. So it's not below, again it's above that line. So if we shade that in, it's above that line there. See there? So now we have to figure out which is the section that satisfies both of those shadings. Okay, so we know it's above that line and above that line, so, and across from that one. So it goes down there, across there, and across the x-axis there, and it's the region there. So if you've got a nice different colour, it's that section all along there. So I suggest you have different colours there, and you write down region required. Or if you shade it, or make sure you specify that this is the region required. So I'll just point it out again. I'll use purple, so I've got a different colour. So it's this region down here, going from there, from that point, down there, to that point, down there, and across there. So it's all the region above there. And make sure you have your corner points all written out. So this one here, let's just write it out properly. So that's 0, 6. This corner point there is 2 2/3, comma 2. This is the next corner point there, which is 8, 0. And they're all the corner points. So, and that means any point in this region and above there is in the region required. So they could all be solutions which satisfy those 4 equations there. Good job everyone. I'll see you next lesson. Bye.